Okay, folks, welcome to Lecture 10. In this lecture, we'll be taking a look at scientific notation and how to perform calculations in scientific notation. So first of all, we'll just take a look at what actually scientific notation looks like. So it's a way of writing either very large numbers or very small numbers, or any kind of number, but it's in this format: a multiplied by 10 to a power. And there's very strict conditions about what scientific notation is. So for a number to be in scientific notation, this value must be between 1 and 10. So greater than 1.0 and less than 10. X then must be a whole number, so a power on 10, an integer, we'd say. Negative or positive, depending on the nature of the number. So we'll take a look. So here we have the number 45. Now we want to write the 45, first of all, in a form that's between 1 and 10. So the only value that's between 1 and 10 is 4.5. So that's where this thing comes from. Now 45 is 4.5 by 10. And then we can always, whenever 10 is on its own, we could always write it as 10 to the power of 1. So in scientific notation, 45 is 4.5 and 10 to the power of 1. So there's two parts to the number. To the value, I suppose, is the best way. We have the number part and we have the power part. 45,000. Now this is 4.5. Again, a value between 1 and 10 by 10,000. And 10,000, we have 4 zeros, so that's 10 to the power of 4. And there's our value in scientific notation. 450 million. It's 4.5 by 100 million. We have 8 zeros, so that's 10 to the power of 8. And this is something I always kind of say is, essentially what you do, guys, is you count the decimal places. So the decimal point was here, and we're now going to move it so it sits between the 4 and the 5 here. So the decimal point has hopped 3, 6, 8 places to the left. And that's what gives us our power of 8. So when the decimal point hops to the left, the power increases. And when it hops to the right, we'll see this on the next slide. But essentially, guys, the power on the 10 is the number of decimal places the decimal point has moved. So this slide, I'm just going to explain that in a little bit more detail. If the decimal point moves to the left, as we did there, it moved 8 places to the left, we increase the power. And then the converse, if the decimal point has to move to the right, we decrease the power. So I always think this kind of looks a bit like a clown. There's a Ronald. So if you kind of remember this, guys, this will always help you as we move along through the later slides. This idea, decimal point moves to the left, increase the power. Similarly, guys, if you need to increase the power, then you move the decimal point to the left. So we'll see as we move through other examples. So now we're going to take a look at scientific notation for values greater than 1. So this value here, convert this value, write it as scientific notation. Well, the first value is going to be 2.38 because that's between 1 and 10. So now the decimal point, I'm moving it to here. It was here, let's move 3, 6, 8 places to the left. Finally now though, it says we also want to write the value correct to two significant figures. So significant figures, guys, only applies to the number part. So that's what we apply significant figures to. So we want to give this value correct to two significant figures. My first significant figure is the 2. We look over, and that means we round up. So my answer correct to two significant figures, 2.4 by 10 to the power of 8. So we look at another one. So here we have 102,100. We want to write this in scientific notation. So this is a tricky one, and I'm trying to kind of test you here, guys. The first value must be less than 10. So it can't be 10.21, it has to be 1.021. Make sure you keep all the zeros in the right place. Here, this 0 is what I'm talking about. Now, we're going to write this as a power on 10. So the decimal point was here. We're moving it to here between the 1 and the 0. It's hopped 3, 5 places to the left. So again, because the decimal point is hopping to the left, I have a positive power. That's a +5, but I don't write the plus in usually. Finally now, correct two significant figures. There's my first significant figure. The 0 is also significant. We look over. This would be 1.0 because we don't round up by 10 to the power of 5. So the first value, 998, because that's between 1 and 10. Decimal point was here. We're moving it 3 places to the left. So it's 10 to the power of 3. So any value greater than 1, all the values we've been looking at are bigger than 1. They all should have a positive power. Finally now, guys, to write this to two significant figures. It's my first significant figure, my second. I look over, this gets rounded up. Now 9 will be one significant figure. It's actually 9.0 by 10 to the power of 3. Two significant figures. So just be careful, you don't just write 9 by 10 to the power of 3. And finally, this would be 2.98. Decimal point has only moved 1 place to the left by 10 to the power of 1. And now to two significant figures. Again, there's my two significant figures. I look over, and again, guys, I have to round up, but I write that's 0. And that's our value there to two significant figures. So we're kind of beginning to combine a few different skills now, significant figures and scientific notation. So now, first question, guys, just pause the video and have a go at the following. Same idea. Be careful though, it's correct to 3 significant figures this time. So I'll let you guys work away at them and I'll continue. Now we're going to look at values less than 1. So 0.45, guys, could be written 4.5 by 1/10. This will be 10 to the power of 1 below the line. And finally, guys, remember when a power is below the line, bring it up and change its sign. So 0.45 written in scientific notation is 4.5 by 10 to the minus 1. And note, the decimal point has hopped to the right one place. And because we're hopping to the right, we subtract 1 from the power. So it's very important, guys, and we'll develop this skill a little bit later in this lecture as well. It's very important that as you move the decimal point, you track it appropriately in the powers. But we'll take a look as we move along. Here, guys, now I'm just predicting decimal point has moved 3 places. Because we're moving to the right, it's going to be a negative power. So that's how you would normally do it, guys. It's just visually. But just to put the maths behind it, that's 4.5 divided by 1,000. And now this value here is 10 to the minus 3. Look at another one. And again, guys, what I would do here, I'd do it visually. So first of all, I need to write my first value as 4.5. I know it's going to be by 10 to the power of something. The decimal point has moved. Don't just count the zeros, it has to move past the 4 as well. So the decimal point has moved 3, 6 places to the right. And that's what gives me my minus 6. Now, when we take a look at the maths behind it, you don't need to do these intermediate steps. These are more just to explain the process, how we get there. So 4.5 by 1 over a million. 1 over a million is 1 over 10 to the power of 6. Power below the line, bring it up and change the sign. Now, in the world of science, guys, 10 to the power of minus 3 is called milli. 10 to the power of minus 6 is called micro. This gets the symbol M and this gets the symbol mu, the Greek letter. So now we'll just take a look at a few examples. So here, like I said, first of all, the first value is going to be 6.095 by 10 to the power. Decimal point is up 3 places and another 2. Because the decimal point, we want it to sit between the 6 and the 0 now. So that's 5 places. But because we're hopping to the right, each time the decimal point hops 1 place to the right, we add minus 1 to the power. Finally now, guys, correct 2 significant figures. There's my first significant figure. There's my second, the 0. We look over. So that means the 0 gets rounded up to a 1. The next example. 2.705 by 10 to the power of 3, 6, 7. 10 to the minus 7. 2 significant figures, we don't round up. And there's my answer. And final one then. So first of all, the number part, 1.2548 by 10 to the power of, that's the first bit. Sort out the number, make sure it sits between 1 and 10. Now the decimal point is going to move to here. We're moving 3 places to the right, so my value on the power is minus 3. I need to write my answer correct to 2 significant figures. there's my two significant figures. I look over, so it would be 1.3 by 10 to the minus 3. So again, guys, we'll just let you have worked through the next few ones. So pause the video. Now this is correct at 3 significant figures. So have a wee go at these ones here. And we'll push on. Okay, so we'll just take a look now. This is kind of, we're going to start balancing figures a little bit, and we can still use the idea of the clown moving to the right, minus is the power, moving to the left, plus is the power. But often we have to balance the values, so it's often good to take a look at a scientific notation value. There's 2 parts. But if you see them as a seesaw, so it's a by 10 to the power of x. So if this side needs to get bigger in value, this side needs to go up, then the other side needs to come down in order for the number to stay balanced. So I'll just show what I mean with a few examples. So say if we have this value here, 0.3 by 10 to the power of 4. Now this looks like it's in scientific notation, but it's not, because 0.3 is less than 1. So we need to make this value bigger. So we're going to write it as 3.0. Now this side has got bigger. Essentially we've multiplied this side by 10. So as a result, to keep the number in the same value, this side here needs to get divided by 10 or multiplied by 10 to the power of minus 1. Remember, that's 1 over 10. So we just add minus 1 to the power, and this is the equivalent value. So you don't even need to do this, guys. You can kind of just think of it as a balancing thing. This side has got bigger, so as a result, this side must get smaller. Similarly, if we have this, again, it looks like it's scientific notation, but now the value is greater than 10. So we need to make this side smaller, write it as 2.0. So the decimal point is hopped 2 places, or really we've divided the left-hand side by 100. So now we need to multiply the right-hand side by 100. We add the powers, and that's our equivalent value there. So we'll see this again and again, guys, and it's a really important skill, is to be able to balance out your scientific notations. If this side gets bigger, this side must get smaller, and vice versa. This side increases, this side must decrease. So we'll take a look at this now in the context of the problems coming up. So here now we're given a value in scientific notation, and we're asked to write it as a number. So there's a few different ways of going about it, guys. If we want to write a number, really we actually want to write it by 10 to the power of 0. Whoops. So essentially this side here is getting smaller. And the question is, what will this side here look like? So essentially, guys, we need to divide this side by 10 to the power of 4. So that means we multiply the other side by 10 to the power of 4, which is 1 with 4 zeros. Essentially, the decimal point is going to move 4 places. It's going to get bigger by 4 places. And that's our answer there. So the decimal point has hopped 4 places in order to compensate for it getting smaller. It's quite hard to explain, guys. It's quite hard to go the other way, but it's very important to be able to do this. So that's that value. Now this is 0.89 by 10 to the minus 2. And you can often just think it through. But first of all, because this is negative, my answer must be less than 1. The decimal point has to be 2 places away. 1, 2. And there's my value written as a number. And it's really kind of an acquired skill as well. It is something you'll have to practice a bit. But just to be able to hop from one to the other at ease is a very important skill as a scientist. And to be able to manipulate these around, as we'll see later on when we're doing units. Here's another one. Now 4.81. First of all, again, I know it's less than 1. So now 0. I need to move the decimal point 5 places. 1, 2, 3. 1, 2, 3, 4. And then 5. That's my 5 decimal places. 81. And you can always check then, guys, you know, if I have to convert it back the other way, decimal point needs to move 5 places, and that will give me 4.81 by 10 to the minus 5. So again, guys, it's just a skill. You need to practice it. The face appears a bit too late and the seesaw, but anyway. That's the basis now of the next question. So again, pause the video and have a wee go at these ones here. Write these values as a number. I'll push on while you guys have a go at them. Now we're going to take a look at calculations. So this is again our multiplying, dividing, adding, subtracting values in scientific notation. And we just take a look at multiplying first. So like fractions, multiplying is actually easier than adding and subtracting. So we'll do multiplying and dividing first, and then we'll do adding and subtracting. So when we're multiplying two values in scientific notation, guys, I'm going to write both values in scientific notation. I'm going to speed it up a bit just to, so the other side will be 5 by 10 to the power of 4. I hope that makes sense. Now I don't really need the point zeros because there's no specifications at the moment. So now, guys, when we have these, numbers do what numbers do. 3 by 5 is just 15. And then, guys, powers do what powers do. We have 10 to the power of 3, 10 to the power of 5 multiplied by 10 to the power of 4. So my power is going to be, we add the powers, 10 to the power of 9. Now, this looks like it's in scientific notation, but it's not. This value, our number part, is greater than 1, so we need to make this smaller. This is where the balancing comes in. This side has got smaller by a factor of 10, so the other side needs to get bigger by a factor of 10. And that's our answer then. Correct to 2 significant figures. That is correct to 2 significant figures. We don't need to adjust it. So there's lots more examples of these, guys, on the video. If you do find these tricky, take a look at the video that's on the Moodle page, and there'll be a couple more examples worked out. We look at dividing now. So now, guys, I'm going to write these as a fraction. 4.5 is on the top by 10 to the power 1, 2, 3, 4, 5, 6, 7, 8. And this is to be divided by 9 by 10 to the power of 4. That's the value on the bottom. Now again, guys, just like with multiplying, numbers do what numbers do. 4.5 divided by 9. Again, if you're unsure, set it up. So numbers do what numbers do, we get 0.5. Powers do what powers do, 10 to the power of 8, top power minus the lower power. That gives us 10 to the power of 4. But now, guys, I need to adjust this value. 0.5 by 10 to the power of 4. The number part is too small. I need to make that bigger. So I've made the left-hand side bigger. So as a result, the right-hand side must get smaller by a factor of 10. And again, two significant figures. That's as we have it. We look at another example. $200 divided by 400 million. Looks odd, but in science we would often get these kind of calculations. So on the top, guys, this part, 2 by 10 to the power of 2. On the bottom we have 4 by 10 to the power of 8. Numbers do what numbers do. 2 divided by 4 is a half. A half is 0.5. Here, guys, again, the powers, be careful. It's the top power minus the bottom power. 10 to the power of minus 6. And now the left-hand side is too small. It's less than 1. So we multiply the left-hand side by 10. And as a result, this side must get smaller, guys. Now be careful. Really what you do is you add minus 1 to the power when it gets smaller. So this will become 10 to the minus 7. And that's our answer then. And again, it's correct. Two significant figures. We don't need to adjust. So that's multiplying and dividing. We'll take a look now. Keep forgetting to bring those in. At adding. Adding can be tricky, and there's two ways to go about it. I'll quickly show you the slow way, but it still works. The slow way, guys, is to convert both back into whole numbers. Decimal point moves 4 places. Decimal point moves 3 places. Add them together. And then convert back into scientific notation. So that's one way of doing it, you know, and it works. If you know what you're doing, it can be quite quick. I'm just double checking I haven't made a mistake. So that's one way of doing it. Another way of doing it, guys, which I kind of prefer, is to balance the powers. The other way then is what I call balancing powers. So we can see the two powers are fairly close together. What I'm going to do is write both of these in terms of the lower power. So we're going to write both as 10 to the power of 3. Now the right hand side is okay. The reason why I'm doing these, guys, is when they're the same powers, then I can add the number value. So this side here, guys, I want this value to get smaller. So as a result, the left-hand side gets bigger. So now I've got 26 by 10 to the power of 3 plus 4 by 10 to the power of 3. Because they're both of the same order of magnitude, we can now add the number bits. And it stays at the same order of magnitude. Finally, now we need to convert back into scientific notation. This side gets smaller, so the right hand side gets bigger. So, like I said, there's two different ways of doing them, whichever you prefer, but generally this method kind of, well, it shows more skill in using scientific notation. It's generally a little bit quicker. So we look at another one, subtraction one. Similar idea. There's a few of our old rules coming back into this. I'm just going to do it with powers, guys. So here I can see I have 10 to the power of 6 and 10 to the power of 8. So I'm going to write both values as 10 to the power of 6. So here, my powers have got smaller by a factor of 100. So the left-hand side must get bigger by a factor of 100. And now, guys, I have this scenario. I have 1.2 by 10 to the power of 6 minus 500 by 10 to the power of 6. So I need to subtract these, but remember, the biggest value has to go on top. And now we get the difference. So first thing, my answer is going to be negative. Let's give me 8. So give me 8. So give me 9. And this is what I get. So the number bit will now give me minus 498.8 by 10 to the power of 6. First thing I'm going to do is adjust it to scientific notation, minus 4.988. This side has got smaller, so this side must get bigger by a factor of 100. Hope that makes sense. And now, guys, the question asks, express your answer correct to two significant figures. There's my two significant figures. I look over, so that means I have to round up. 5.0 by 10 to the power of 8. And that's our answer. Even though it looks like it's part of the problem, correct to two significant figures. That's our answer there. So, there's just the face and the seesaw. Now we'll just take a look at one more problem and then we'll finish up. So this is kind of a combination type problem. It involves all the skills. And similar to before, guys, even though it looks very complicated, if you break it down into chunks, then everything will work out just fine. So I'm going to work out the top line first. So here, guys, I have 3.2 by 10 to the power of 2, and it's been divided by 8 by 10 to the power of 4. So staying with that top line, numbers do what numbers do. This will give me 0.4. Now be careful, powers do what powers do. We have 10 to the power of 2 minus 10 to the power of 4. So that's going to give me 10 to the minus 2. And now I can leave it like this if I want, guys, because I'm still in the middle of a calculation, but I'm going to just write it in scientific notation just to practice. This side gets bigger, so the other side gets smaller, and be careful there. Minus 3 is smaller than minus 2. So that's the top line worked out, guys. Now I'm going to work on the bottom line. This is addition, so I'm going to write it as 24. Bring everything down to 10 to the power of 2 plus 6 by 10 to the power of 2. Now we've got the orders of magnitude matched, so we can add the values. And finally write this in scientific notation. This side gets smaller, so that side gets bigger. And now, guys, we're in a division type problem. Numbers do what numbers do. We're going to have 4 divided by 3, which gives us 1.333. and then powers do what powers do. Be very careful. The top power minus the bottom power. And often put brackets around the bottom power, especially if there's a minus involved. This will give us 10 to the minus 6. Finally then, it asks us to write our answer correct to two significant figures. So we get 1.3 by 10 to the power of minus 6. Okay, folks, so that pretty much finishes up for here, but we just need to take a look at the last set of questions, which are on this slide here. So question 10.4. So I'll let you guys take those down, have a go at them, and we'll finish up here then.